Okay. So let's talk about permutations and combinations. This goes hand in hand with the fundamental counting principle. You also will use this a lot when you get into more probability problems. We will not get that far into probability this year. And that's kind of the bummer, where if I had 2 extra days to teach lessons, that's what I would go over, using permutations and combinations to find probability things. But that's okay. We're scratching the surface, and I'm okay with that. So we're going to start with permutations. Actually, that said, give me 1 second. Okay. So permutations, the number of permutations n times of a set arranged items at a time is this formula. Now, again, that's super confusing. We'll talk about what that is. Basically, we're going to start with just doing of these 7 permutation 2, 10 permutation 7, so on and so forth. Then we'll talk about what the story problems look, or how they look. So those are the 2 you're trying to make distinctions from. You also have to make sure it's a little bit different than fundamental counting principle. We'll talk about that in a second. I've got a chart on the back about that. So, couple things. First off, your first number, when they talk about the n's and r's, your first number is always bigger than that second number. So I have a lot of students that the thing they struggle with is they don't know which one comes first. And the rule of thumb is you'll always have the bigger numbers first. In everyday life, it might not go first, but that'll be like, this is not an exact example, so later you can't be like, actually, you're wrong with that. But it'd be like if I said, remember yesterday we did the example of chairs. We had 5 chairs up here. How many ways can we fit 5 people in there? It'd be something like, we have 5 chairs. How many ways can we fit 10 people in those chairs? Well, you can't really, because there's only 5 chairs. So that's kind of what that example would be like, where I guess it's not possible. But for our purposes, that first number, that n, will always be bigger. And the formula we will use is this one, where you have n with your factorial, and then you take those 2 numbers and subtract those factorial. Now, it says over here, so that is for when r is bigger than 0 and n is bigger than r. That's great, but like I said, I'm not going to be tricky. You don't have to worry about that part at all. As long as you know how to use that formula, that's the main thing. And again, I will give you that formula on the test when we take it. For your quiz, though, you just need to make sure you save these notes, because you can use notes, so I'm not going to give you any formula sheet for that. So, the punchline of this one, permutation 2, what would that end up being? That would be 7 factorial over 7 minus 2 factorial. Reduces down then to 7 factorial over 7 minus 2, 5 factorial. Now, there's 2 ways to do this from here. The first way is I really kind of just show you, because it's good to see how this works. So you don't have to write this out, because you probably won't have room. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. 5 factorial times 4 times 3 times 2 times 1. So if you're actually solving this by hand, it actually works out pretty nicely, because remember how we have things in our last chapter, we said as long as it's multiplying and we have the same thing in top and bottom, we can cancel. So 5 and 5 will cancel, 4 and 4, 3 and 3, 2 and 2, 1 and 1 will cancel. So this whole thing is the same thing as just 7 times 6. So this should just be 42. For our purposes, I will tell you, and this is where I always go back and forth, where I probably should make you show one of those things, but that's okay. We won't do that this year. So this should be 42, but for our purposes, I need to see at least one of these things. To show your work, I need to see one of those fractions. However, you can type it into your calculator. 7 permutation 2. In your calculator, if you're using one of mine, the factorial button is right up here. It's right below your mode or your setup button. So you have to hit the shift, and then you have to hit that to get factorial. So you could do that. You could literally type in your calculator, 7 factorial over 5 factorial, and enter. It should give you 42. However, the other way down below, and it kind of bothers me that it's way down here because usually it's right the same place as that factorial. But down below your delete and your clear buttons, kind of covered those up. I guess multiplying and dividing, those two buttons have an NPR and an NCR. Those are the permutation and combinations we're using. So that would be the way you type that in your calculator. So I imagine you'd hit the 7 first, then you'd hit that permutation button. So you'd have to hit shift permutation and then hit the 2. I think that's probably how you do it. That should give you that answer. If you're using a graphing calculator like this, it's a little bit more involved. If you don't know where that is, or if you want extra help on that, let me know. It's one of those things that with a graphing calculator, it's really a lot more powerful, but a lot of this stuff is hidden a little bit more in there. So just to double check, 7 permutation 2 ends up being 42. So we're right about that. I'm going to make you, and maybe I should, but I'm not going to make you show me all the work for those. It's a button in your calculator. I'm okay with you using that. However, you do show me at least one of these fractions to get full credit. Like, well, I have to show you a fraction to get full credit when I do my calculator. Then I'll just make you show all of it and get credit, and then that's going to be more. It's not a bad idea, though. So the next one, we have 10 permutation 7. Again, definitely out of the fraction, or you need to write out one of the fractions. So that is 10 factorial over 10 minus 7 factorial. For some of you guys, you'll start getting good at this. You'll do this in your head where you know 10 minus 7 is 3. It gets to be a little bit more, and it's not a huge deal. I mean, it's not hard, it just takes a while. But if you're doing this one by hand, we have 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 factorial 3 times 2 times 1. So when these cancel out, it doesn't cancel out a lot of these. You'd have to type all that in your calculator still. 10 times 9 times 8 times 7 times 6 times 5 times 4. So that's why using the permutation does end up being a little bit nicer. But again, I need to see one of these fractions to get full credit. Then if you want to type in 10 permutation 7, obviously that's going to be a bigger number. We have 6,004, sorry, I have to write it before I say it because there's no commas. 604,800. So the last one, again, don't make this harder than it is. 15 factorial over 15 minus 9 factorial. Now, one thing you can also know is maybe it's 15 minus 9, not 9 minus 15. But again, obviously, that's going to give you a negative answer. You won't have any negative stuff in this one, so you don't have to worry too much about that. And again, some of you guys will do this in your head. You don't just jump to this step. That's absolutely fine, but I would like to see one of those parentheses. And then again, from here, just type it in your calculator. I can live with that. 15 permutation 9. Oh, it's a big one. 1,816,214,400. So that's what? 1,816,214,400. And again, this is one of the chapters that one of the reasons I like it is if you would have gotten that question, that answer before this in any chapter, you'd think, well, I obviously made a mistake. Why would I get a number that's 1 billion? Well, in this one, it gets a little bit more commonplace to get some of those weird looking answers, some of those really big ones. Okay. Okay. I almost forgot what these blanks were supposed to be, so I was panicking. So now obviously we're going to use these for some story problems. And honestly, if it makes much difference to you, I don't know if this is good news or bad news. The hardest part of this lesson today is making sure you know when to use permutation compared to use when the other one that we'll do in a second is called combination. When to use which one, I think is the biggest battle. Now that all said, again, I think I broke it down pretty nicely that we'll go over on the back. A couple years ago, I made a list on when to use what, and I think that really helped students, so I'm hoping that's not a huge issue. But counting how many ways to arrange n items into r different places when the order of the items matters. If the order definitely matters, if the order doesn't really matter, it's going to be combination. This is where I would like to give you some sort of really quick example, but I think if I do, I'm going to butcher it. I have to think about it a little bit. But again, we'll go over when to tell which. Basically, I'm trying not to give you a super generic one, or I'm trying to think of a super generic one, but I'm scared it's going to be the wrong one. But that's how closely these are related to each other. And again, like I said, once we get into this, I think it'll be okay once we see the difference. So let's get into some of these examples. So again, make sure your number has to be first. Sometimes when people do this, which one's the R? The big one's always the N. So that came out very fuzzy. So number one says 10 students are in a race. First, second, and third places will win a medal. How many ways can 10 runners finish first, second, and third? There's no ties allowed. So, but again, I know it's a permutation section. Once we don't know, once we have to decide if it's a permutation or combination, it gets to be a little bit more difficult. But we know it's permutation, so that's good. But this is why it's a permutation. It's a permutation because the order matters. The person that gets first is an important thing. The person that gets second, that matters. Who gets second? The person that gets third, that matters. Who gets third. So the order is very important in this. Obviously, if you don't think the order is important, then you should race somebody or talk to somebody in track. The order is definitely important with that. So there are 10 permutation. The next one. Well, still 3 spots. First, second, third. So that is 10 permutation 3. If they would have said instead of first, second, third place, if they would have said first, second, third, fourth, and fifth, then that number would have been 5. But since they only say first, second, third place wins medals, or if you get 7th place, it doesn't make any difference between those two. They don't win medals, they don't get points. If you get 4th place, you might as well have last place. That's not true if you're in track. I'm not diminishing you, but for mathematical purpose, we don't care about your feelings. 3, once you have that, the rest of this isn't too bad. Again, just make sure you please set up your fraction, because I do want to make sure you, I guess I would like you to be able to do this if you didn't have anything besides like a normal add, subtract, multiply, divide calculator. I'd like you to be able to struggle through this if you had to. It's 10 minus 3 factorial, so it's 10 factorial or 7 factorial. And again, either one of those you want to put in your calculator is fine. I'm going to put my original one in. That way, if I make any mistakes, I at least will have the right answer. Whoops. 10 permutation 3. So there are 720 different ways that those 10 runners can get first, second, third. And again, keep in mind that if the order does matter. So when I say that, what I mean is if out of those 10 people we have Tom, Bill, and John, then if Tom finishes first, then Bill, then John, that's completely different than if John finishes first, then Bill. Or if Tom finishes first and then the other two. Just those slight differences, those matter. That definitely is a big difference. And again, once we get into the combinations, I'll compare those two, and you'll see what I mean. You'll see the difference between those. A lot of times it's really hard to tell the difference until you have 2 questions side by side where they are very, very similar, but one's permutation, one's combination. I put one of those on there. If not, that I can think of off the top of my head very quickly. Number 2, 15 students asked to visit a college administration or admissions counselor. They scheduled visits include 1 student. How many ways can 10 time slots be assigned? So when you are signing up for college courses, I mean, similar to high school where you set up a meeting with the counselors, If you look at their schedule, so this one, there are 10 different slots to be assigned. There are 15 students that need to sign into those 10 slots. So 5 people are going to miss that. They'll have to do a different day. So again, 15 students to appointment for 10 different time slots. 15, 10. Now for this one, it's really hard to tell that the order matters, but the big deal with this one is that when they're specific, when they're talking about scheduling like that, that is going to be, order is going to matter if they're talking about scheduling things. So that ends up being 15 factorial over 15 minus 10 factorial. So that is 15 factorial over 5 factorial. And again, for me, I would type that in my calculator. I would type the original one in. You could type both in just to double check your work. That's not a bad idea. This example. So my calculator gives me 1.08, I guess I'll go another couple decimals, 97, but then it says e to the 10th, or E10. That's scientific notation. Short way of saying that's 1.0897 times 10 raised to the 10th. So that's a really big number. If how you show your work, I will try really hard to make sure your quiz like that. But either way you want to write it, as long as you copy down what's in your calculator. Again, if there's one like that on a quiz, that's my fault. So as long as you show me that you understand that you have the right answer, I will on how you write that. That I should change. Any questions on permutations yet? Order matters for number 2. The best thing for you is it just doesn't. Every time you have a scheduling problem, it's going to be like that. That's something that I, on purpose, go over that every time because it's still hard for me to figure out. Okay, now moving on to combination. Now, not necessarily for this class, but if we would go any deeper, the combination method, or this one, is actually way, way more popular or way more common. We do a lot more. We're not really going to do much more with it because we're not going to go in too much of depth. So it basically has the same exact definition. It's just a different formula. The biggest difference is it's n factorial on top of the numerator, just like the other one. But then now, before you subtract, you have the r factorial. So I'm going to show you this. I'm going to show you a little bit of a shortcut. 10 times 7 is how you would read that. It is 10 factorial over the r7. 7 factorial times 10 minus 7 factorial. Simplify that out. That is 10 factorial over 7 factorial times 3 factorial. Again, I don't care which one of those you show, you have to show me one. Now, this is one of the rare occurrences I will tell you. Actually, skip that first one. Because the way it's easier for me to memorize this formula, and I still show you the old one, the easiest way for me to memorize this formula is that these two numbers on bottom add up to be that top number. Add up to be 10. So for instance, the next one, I know it has to be 7. I know the bottom one has to start with 2. So let it be 5. Be 2 because that's this number. So again, for me, I skip that first step because honestly, it's just easier for me to remember. It's easier for me to comprehend. Where I just know those two bottom numbers add up to be the 7. I know the thing they gave me. I know they gave me. So then to figure out the 5 isn't really that hard of a deal. Now, to put these in your calculator, again, it's the same thing we talked about before. It's just the button right beside the permutation. For these calculators, they're on the division sign. Again, calculator, if you can't find it, let me know. So we have 10 combination 7. This one is 120. Whoops. And 7 combination 2 is 21. Next one, 15 combination 9. Again, for me personally, I do 15 factorial, and then the denominator, I know it's going to be 9 factorial, and then 9 plus what gives me 15? I know it's got to be 6. You do not have to do it that way. You can still take 15 minus 9. That's fine. Again, as long as you know that to double check, I think that helps. And then if you type that in your calculator, 15 combination 9 is 5,005. So as you can imagine, how many ways you can arrange n items into r places when the order of the items does not matter. Now, obviously, probably just looking at this, you can tell, but there should be less combinations than permutations. There's less options for combination than permutation. We'll talk about that in a second as well. So I put this example up here really quickly. In permutations, first 1, 2, and 3, 2, 1. In permutations, what we just did earlier, so 1, 2, 3 is completely different than 2, 1, 3. Whereas if the order doesn't matter, then it doesn't matter if it's 1, 2, 3 or 2, 1, 3 or 3, 1, 2. The order doesn't matter. It's the same 3 numbers. So that's the biggest difference between permutation and combination. And that's the reason why combination, you have way less options, because whether it's 1, 2, 3 or 3, 2, 1 or 2, 1, 3, those are all the same exact makeup. Those are the same exact option. Whereas permutation, all 3 of those would be 3 totally different things, because permutation, the order matters. So one example I gave, and it's because the first example I did with permutation. With permutation, the difference is there's a first place, a second place, and a third place. Those are very distinct differences. Whereas the other one is just if you're picking 3 people. It doesn't matter who you pick first, who you pick second, who's the last one. You're just saying, you 3, go run this race. Or my favorite example is, and I think I maybe have this in here. My favorite example is if you have a committee of 10 people, I guess it'd be similar to one. Oh, no, it's not. If you had a committee of 10 people and you're choosing a president, vice president, and secretary, the order definitely matters. Your president, your vice president, all that stuff is going to be different the way you make that up. Whereas if you have the same committee of 10 people and you're going to pick 3 people to come help me carry a table, doesn't really matter what order you pick those 3 people, they're all going to come help me carry a table. So that's one of my other favorite examples of permutation is where they have a specific order. The order definitely matters. Combination is when the order doesn't really matter. You just need 3 people. Okay. So again, I tried to draw the difference with this first one. There are 10 students in a race. The top 3 finishers go on to the championship race. So again, I apologize. I did track a lot in high school and I coached for a little bit. So I apologize if this isn't commonplace. But what happens a lot in track in the bigger meets is you will run a race with 10 people. Whoever gets the top 3 will then go on and advance to the next tier where they then race to get first, second, and third. So it doesn't matter if you get first place. It doesn't matter if you get first, second, or third. You still run the same place everybody else is running. So this one, the top 3 finishers advance. It doesn't matter if you got first, second, or third. You're still moving on. So that is. It doesn't matter. It's just 3 people. There's no ranking system. It's just the top 3. So we have 10 students racing. It's combination because the order doesn't matter. 10 combinations. Please show me the work. It's 10 factorial over 3 factorial times 7 factorial. Again, the 3 here, and then I know the 3 and the 7 add up to be 10. And then I put that in my calculator. 10 combination 3 is 120. 120 different ways. And again, if you compare that to earlier, there were 720 different ways. And again, it's because if the order matters, there's way more different options. There's way more different combinations. Number 4, a biology teacher divides a class into 8 groups. Each group submits 1 drawing of a cell. He will select 4 drawings to display. How many different ways can he select the drawing? So there are 8 groups. He's selecting 1 drawing from each. He's selecting 4 drawings. So there's 8 drawings. He's picking 4 of them. He's selecting 4 of them. So I know 8 and 4 is a permutation combination, again, because he's not saying he's picking the 4 best ones, or he's putting them up on the wall in order from the best to the worst, or awarding the first 3, first, second, third. He's just picking 4 of them. He's not saying that when he hangs them on the wall, he's not saying the first one goes best, the best one goes first, the worst one goes last. He's not saying any of that. He's just picking 4 to hang on the wall. So the order does not matter. That's combination. So again, once you have that, the rest of this shouldn't be too bad. Eight factorial over 4 times 4, 4 factorial times 4 factorial. And again, I'm going to type out the original in my calculator. Sorry, I'm getting, what are we at here? That is 70. Before I move on, as long as you know how to set up the combination with the fraction and put in your calculator, as long as you understand that, if you're still kind of hazy on when to use which way, again, the next thing I'm going to talk about is I'm going to do some examples. I'm going to show you a list where I put some things side by side, and I think it's a really good way to clarify a lot of things. Obviously, on your quiz, you can use it because it's on your notes. You won't be able to use it on the test. On the test, you're just going to have to either memorize it or study it or go over enough examples that you need it. You don't need it. But again, the good news with Algebra 2, at least for me and most classes I've ever taught or teachers I've taught with, there's not like 1,000 different things you'll see. Most of the questions fall under certain categories. So it's not like the end of the world to sit down and actually memorize these. And again, in fact, if you guys do your worksheet, if you do your quiz, if you do your practice test, by the time you actually take the test, you've done enough of these that you really are kind of have memorized already. Okay. So when to use what one? Permutation versus combination. So again, obviously the permutation I already put at the top, the order matters. The combination, the order doesn't matter. So when I say the order doesn't matter, it means it doesn't change the outcome at all. So again, if Joe, Bob, and Bill are going to carry a desk, it doesn't matter if it's Joe, Bob, and Bill, Bill, Bob, and Joe. It doesn't matter what order. It's still those 3 people come help me carry a desk. So those are the overall differences, but now I'm going to go into specifics. So if they're ever ranking something, it's permutation. So if they say president, vice president, secretary, or president, treasurer, and janitor, I don't know what other ranks there are. If they're ranking something, then it definitely matters. So same thing, if you're getting first, second, third, or fourth, that's ranking something. First, second, third, fourth, fifth, that's ranking. Best to worst, that's ranking. If they're doing some sort of ranking system, then that's definitely permutation. If they use the word distinct, if there are different distinct terms, that means permutation. And again, I don't know why this one is in there, to be honest. I'm sure I could probably look it up, and I'm sure at one time I knew. But scheduling, if you're working with scheduling, like I talked about the college admissions, that order does matter. Maybe it's because if you go first, you have your first picks of the classes. I don't know. Serial numbers and passcodes. Obviously, the order matters. If your password is 1234 and you accidentally type in 1243, you're not going to get in. So obviously, serial numbers or passcodes, the order definitely matters. Very, very vague one that kind of is a blanket statement. But one thing I found after teaching these is permutation are usually the ones that are way more detailed. Like, again, you have a class of 10 people, you're picking a president, vice president, or secretary. They're being very specific. They're telling you specific roles, whereas combination would be like, you're picking 3 people. That's pretty vague. It doesn't really specify what things are what. So usually they're more detailed. And then this one, honestly, has not really worked for me too well, but I know a lot of teachers that say, when you hear the word permutation, think position. It's different positions it's in. Now, combinations, and this is kind of a cop-out, but it's the ones that aren't those. So combinations are when the outcomes don't matter. So if it's, again, like I said earlier, 1, 2, 3, and 3, 2, 1, those are the same outcome because the order doesn't matter. They're usually less detailed. And then again, at the end, it's not permutation. Rankings, it's combination. If they don't have distinct patterns, it's combination. If it is not a serial or a passcode number. So that's usually you can look at that and you can tell a difference. Now, under that, I also typed out some examples. Oh, never mind. Okay. So the other thing that didn't dawn on me is I've also had some people that get confused when to use permutations and combinations and when to use the counting principle we did yesterday. So the counting principle where you said, okay, well, it's 4 pairs of socks, 5 shirts, and 2 shoes, so it's 4 times 5 times 2. So when to use which one? So with permutation and combination, it's when you have one category that you're choosing multiple people from. So again, a class of 25, I'm picking 10 of them to go down to the hall and get something. You have one group of people, I'm choosing multiple people from that group. The counting principle, a lot more often, is usually where you have several different groups and you're picking one from each group. So again, you have t-shirts, pants, and socks, you're only choosing one from each one. If they're a license plate or phone number questions, a lot of times it's easier to use counting principle on those. Or if they are talking about how many people to sit in a row or how many ways to put pictures in a row, how many ways to line up, usually those are counting principle. Now, if you know enough, if you're familiar enough with this, you can use permutations and combinations. It gets more confusing. And again, I put a couple examples at the end here. Permutation and combination, 10 people, I'm picking 4 to help me carry something. That would hopefully obviously be combination. Whereas on the other side, you're picking outfits from 4 shirts, 3 shoes, 6 pants. Again, combination permutation, there's 10 people, you're picking multiple people from that group. Whereas the counting principle, you have several different things, you're picking one from each. Or again, how many different license plates with 3 letters and 3 digits? That would definitely be easier with counting principle. So for the rest of these, go ahead and do these on your own. If you don't actually, well, it shouldn't take long. If we're being honest, I imagine, no, that's good. So these can be permutations, combinations, or counting principle. Now, again, there are some that you can use both ways, depending on what you are, or what your strengths are. But for all these, go ahead and do these on your own. In my opinion, actually, if you want to save a little bit of time, if you don't want to solve them and you just want to write down permutation, combination, or counting principle, that's kind of the main point of this exercise. If you want to save time, you can do that. But I'm going to put the answers up here in a second. If you have any questions, let me know. All right, these are the answers I had. And again, there's different ways to do all these. Just quick explanation. Again, 5 and 6, I'm going to be, I need to go in and edit. I'm going to make number 5 a little bit more specifically permutation, which will help. 6 is a little bit more specifically combination. And number 6 makes sense. If it's 5 people running a race, how many different ways can 5 people finish? Well, there's only one way because they all finish, unless there's somebody that doesn't finish, which is not really happening in this. Then number 7, the difference with this one, again, hopefully it's a little obvious. We have 3 different groups. We don't just have runners anymore. Number 5 and number 6, we had 5 people running a race. Number 7, we have 3 sprinters, 2 high jumpers, and 5 distance runners. So I have 3 groups of people. I'm picking one person from each group. Now, technically, the other way you could have done that is, I think it would be combination. 3 combination 1 times 2 combination 1 times, and that, I mean, it's possible. It's just not ideal with this. So that, again, is more directed towards fundamental counting principle. Number 8, hopefully that one, and that's more typical what you'll see on a test or a quiz. There's 10 people, there's president, vice president, secretary, so there's 10 permutation 3, because permutation, the order matters. That's that ranking system. Now, number 9, there's 2 different ways to do this. Now, the way I would do this is I would do it the same way with the counting principle, and that's what I said up here in my list, where it's how many ways can you hang 10 pictures in a row where you're lining things up or something like that. Hanging pictures is on there. So I think it's easier to think of that with the counting principle, but also you could have said, well, it's permutation because the order matters. Whatever book you put first, you can't put anywhere else. So the order matters, and there's 8 permutation and there's 8 spots. So 8 permutation 8, it's the same thing. The math all works out to where it ends up being 8 factorial. So that's a place where, yeah, either way actually works. I think it's easier to think of the fundamental counting principle. But yes, the order matters because you're lining them up specifically. So 8 permutation, and then again, there's 8 spots. And last one, 10, the teacher chooses 4 students to help move a table. That's the example I've used over and over. So that's definitely combination. It doesn't matter which order those go in. Again, most of the time on a test or a quiz, you're going to have problems a lot more like number 8 and number 10. Because I'm trying not to like trick you super bad. As long as you know which way is which, I don't want to try to give you tricky ones that. If you have any questions, let me know. Tomorrow's lesson, I'm not going to say is easier, but it should be a lot quicker.